Good afternoon and welcome to today's webinar on resilient PNT for unmanned systems, hosted by Infinidome and Aurelia. My name is Omer Sharar, CEO of Infinidome, and we're also fortunate to be joined by 4 other excellent speakers today. Mr. Dana Goward, President of Resilient Navigation and Timing Foundation, RNTF&D. Mr. James Platt, Chief of Strategic Defense Initiatives for the U.S. Department of Homeland Security, the DHS. Ms. Karen Van Dyke, Director of PNT for the U.S. Department of Transportation. And of course, Mr. John Fisher, Vice President of Advanced R&D for Aurelia. Now, before we get started, we've got a few housekeeping items to cover. This webinar is being recorded for those who are unable to join us live today. We encourage you to submit questions during the meeting through the question panel you see here on the right. Our speakers will answer as many questions as possible during the Q&A towards the end of the meeting. If for some reason you lose your connection to the meeting, you can join again using the same meeting link you used to get in. Our agenda for today includes presentations from each of our speakers. Dana Goward will begin with an overview of resilient PNT positioning, navigation, and timing challenges, followed by Jim Platt, who will give us the U.S. Department of Homeland Security perspective, and Karen Van Dyke will share information from the U.S. Department of Transportation. We'll then turn to industry, where John Fisher and I will present 2 unmanned systems case studies. And we'll finish up with a Q&A and roundtable and next steps. And now I'd like to turn the meeting over to Mr. Dana Goward. Dana, take it away.
Thank you, Omer, and good afternoon or good morning to everyone, depending upon where you are. So up front, I need to tell you that the RNT Foundation is a scientific and educational charity. So like the government folks here on this webinar, we can't and we don't endorse any specific products or services. We certainly do appreciate being able to participate in this this webinar. And in full disclosure, Aurelia is one of our corporate supporters. So unmanned systems need resilient PNT, but you probably don't have it. Now, part of the reason is that it's not generally available. Most folks for positioning, navigation, and timing use GPS or another global navigation satellite system. And while they generally tend to be really, really good and very accurate, the signals from them are exceptionally weak. They are so weak, as a matter of fact, that just the humming of the sun and the stars makes more noise than a GPS satellite. Not a problem when things are working well, because our very smart receivers look down in the noise floor and winkle out the coded signals. But it also means that any kind of other signal on the frequency, I'm trying to advance. There we go. Any other signal on the frequency tends to block out or jam reception of GPS signals. And you have situations like this one here. This is a accident report from the United Kingdom, where someone was apparently driving by, or probably not driving by because it persisted for a while. Someone in the area had a personal jammer in their vehicle to avoid being tracked by their employer or their ex-spouse or whatever. And the GPS navigation was lost to a drone. The wind caught it and carried it away before the drone operator could take manual control, and it collided and crashed into a house. A drone that was large enough to cause serious injury or death, according to the report, if it had hit someone. And I say that the person probably didn't drive away right away, because the second drone that they sent after it to look for this one also experienced a lack of navigation and had to be immediately landed, so it also would not get lost. But you know, that's a bad thing, and when you can't receive GPS signals or when they're interrupted. But it can be even worse. Because all of the providers of satellite navigation services want their systems to be widely adopted and used by all, they make the characteristics of those signals widely known. So that means that in addition to being easy to jam or block, they're easy to deceive or spoof, imitate. Here is an example of a company that was able to take over a Tesla's automated driving program sufficiently in order to make it exit the highway early. And we see these kinds of things certainly in an academic setting on a regular basis. And it doesn't really matter if you are using multiple GPS or GNSS constellations, say if you use the European Galileo and the American GPS system, because folks have demonstrated that it's relatively easy, about $153 worth of equipment to imitate them all at the same time and take over or at least deceive a navigation system. So this is these are all academic papers, though. These are all white hat hacking kinds of things. Does this really happen in the real world? Well, I'm afraid to say that that it does. It's very difficult to get an Uber in Moscow many times, especially if you're near the Kremlin. And frequently, depending upon where VIPs in Russia are moving around the country, GPS receivers are spoofed across wide areas. Normally, what will happen is that, as in this case with ships at sea, their GPS receivers will report that they are actually at airports. This particular study identified almost 3,000 instances of ships reporting that they were not at sea, but they were safely moored in the middle of a runway at an airport somewhere over the course of this almost 2-year period. And it's certainly not something that, by the way, this the intelligence community, or perhaps I should say the observers of the intelligence community, because certainly don't have access to the US intelligence community anymore. But observers of these kinds of phenomena believe that this is almost certainly a VIP protection program to protect them against drones. As many of you know, most drones are programmed at the factory to fly away from airports. So the idea is if you make the vicinity of a VIP look like electronically that it's at that it is at an airport, a drone will fly away from that. And so it won't be photographing or otherwise harassing or endangering the VIP. So naturally, you can imagine it's not just the Russians that do this sort of thing. We have seen this in Iran and other locations. And we also see it in China. So whereas the Russians have figured out a way to spoof GPS receivers across a very broad area into thinking they're at one location, airports, the Chinese apparently have attempted to figure out a way to spoof GPS receivers across a broad area to what they think is random locations. But as you can see in this time-lapse video here, what actually happens is that many of the receivers get spoofed to locations that are on the rim of a circle that seems to almost bullseye where the spoofing device is located. You can imagine that the engineer who built the equipment was probably surprised to find after this data had been accumulated that this phenomena happened. But there you are. That's the way that there's something about the hardware and the software that seems to make this happen. Okay, let me see if I can. Nope, try and advance the slide. There we go. So this this technology also seems to have gotten out onto the dark market as well, because we have seen ships from across the globe report that their locations are actually way, way far away, thousands of miles away, off the coast of Northern California, and to report that their ships are making big circles off Point Reyes. So this isn't something clearly that is just the province of intelligence services or nation states. Like all technologies, the longer it goes, the less expensive, the easier to use it gets. And it's pretty clear that folks on these ships in various parts of the globe have been using it to hide their activities. for one reason or another. So what do we want to do about that? So our educational and scientific nonprofit advocates the same holistic approach to this problem as the National PNT Advisory Board does. So we talk about protecting the signals, toughening users and equipment, which I'm sure is a big thing of a lot of folks on the call today, and augmenting it with other sources. So protecting the signals. That means not allowing folks to transmit intentionally on the frequency, and when they do, finding out about it and sanctioning them so they don't do it again. It also means monitoring the frequency so you know when that's happening. The graph there is part of a report from the European Union where they did a 2-year set of samplings, and they found just in their samplings over 500,000 instances of signals on GPS and GNSS frequencies that could cause problems with reception. Now, only about 10% of those they judged were intentional. The others were just random noise. But you know, it really doesn't matter if your drone is flying off because it can't receive GPS as to why the GPS signal is lost. It's just that it is. So it's a good it's a good example of how just fragile and how often these transmissions are interrupted. And then, of course, as I mentioned, when violators are found, sanctioning them to set an example for others and ensure that they don't do it again. So toughening, what does that mean? Well, it means using better hardware and software on your receiver to make it less susceptible to jamming and spoofing. And while we can't endorse any particular product or service or company, and there are a number of companies that offer these kind of products and services, here are 2 examples of that equipment. Just happen to be from Infinidome and Aurelia, which are fine companies indeed. Finally, the third part of our holistic approach is augmenting the signal. So providing users something to use in conjunction with a GPS or GNSS so that the signals from space are not a single point of failure. This is a notional architecture that was published by the US government in 2008 that shows a variety of positioning, navigation, and timing sources that folks could access so that regardless of which part of the architecture, which set of signals and sources was being disrupted, other opportunities would be available. Unfortunately, while this was published in 2008, not much has been done to widely provide these kinds of signals and sources to folks. This idea of a more holistic, multi-source PNT architecture was recently revived in the U.S. Department of Defense's strategy for PNT, and it's certainly something that we endorse. And perhaps equally important, it is something that other nations are taking to heart. We have seen the Russian radio navigation plan talk about strong reliance on terrestrial PNT in conjunction with PNT from space. And the most complete concept anyway, although we haven't seen a plan, was put forward by China at last year's Stanford PNT Symposium, where they talked about 3 levels of satellites, geostationary, medium Earth orbit, and low Earth orbit. They have some satellites in each of those orbits right now providing PNT, ground-based systems like LORAN, autonomous systems like inertial, and all number of systems that they intend to develop. Certainly a very robust approach for both their government sources and their citizens as a whole. So this is something where we in the United States could do well to perhaps reassess and catch up. Certainly something that we at the R&T Foundation advocate, and in fact, we have recently published a paper on a resilient national timing architecture. Now, timing is really the underpinning for PNT. Wireless navigation systems generally rely very heavily on timing. And this approach, where as you can see that it has 3 phases, in its final phase would provide a very accurate level of timing both via fiber and wireless connections across the United States. And because we wanted to serve mobile timing receivers as well, independent of space-based signals, we also provide, the system also provides for a non-space-based positioning and navigation service also. Now, this in and of itself would not be quite as accurate as GPS, might be only 5 or 10 meters, as opposed to GPS's a typical service of about a meter of accuracy. However, it would provide a very solid timing backbone for other systems that could be developed perhaps from 5G or for autonomous corridors in urban areas and suburban areas and in between on major routes, and essentially enable not only very solid GPS and GNSS reception when the services were available, but a graceful fallback and an opportunity to build additional services to support more precise navigation, perhaps down to the decimeter level for autonomy. So that's where we are. Thank you for your time, and I look forward to the questions at the end of the other presentations. And now over to, I think over to Jim, yes?
Yes, good afternoon, everybody. I'm Jim Platt. I'm the Chief of Strategic Defense Initiatives within the Department of Homeland Security. And what I'd just take a little bit different spin from, or not spin, but perspective from the previous panelist, Dana. Dana talked a lot about the spoofing and the jamming and the things that are taking place all over the world. And those things are certainly a concern for the Department of Homeland Security. And these, while they've become more prevalent, a lot of these things are not new. So to address that, we've realized that we had to take a look at where we are now with the current position navigation and timing systems, and we needed to address the situation now and not potentially wait for future developments and the deployment of position navigation and timing systems. So what we've done is we took a step back and looked at this, and then across the federal government we took a look, and we got together and we came up with the concept of the responsible use of position navigation and timing. And people ask us all the time, what does that really mean? And people call this the PNT EO. I like to go use the full name of it and say it's strengthening national resilience through the responsible use of position navigation and timing. And people say, well, what does responsible use of position navigation and timing mean? And I'll give you an example. It seems like a simple example, but I think it really illustrates the point. Just about every few months, you can find somewhere in the news where an individual is driving along the road and the GPS signal says turn right in 500 meters, and a little bit later it says turn right in 100 meters, and then turn right, and people turn into a lake. Even though they jump over a curb, they drive across grass, and they finally drive into the lake. And you would think this is something that wouldn't happen that frequently, because the driver has numerous situational awareness clues around him or her looking out the front windshield, and yet they still make the mistakes. And it's because people have become conditioned that GPS is always going to be there and GPS is always going to be available. And so when we talk about the responsible use of GPS, we can no longer continue to develop systems such that they always assume that GPS is going to be there, and that GPS is always going to be, or the signal you're getting is always going to be reliable. And that is not to cast doubt about the GPS system. The GPS system is one of the most prolific systems around the world. It is extremely accurate. It's extremely reliable. And people ask me if I can trust GPS, and I tell them you can trust GPS. Just be sure that the signal you're getting is coming from GPS or from one of the other GNSS signals, because as you saw from Dana's presentation, it's relatively simple for those other or for the GPS signal to be jammed or to be spoofed. So when we talk about responsible use of PNT, as we're designing systems in the future and we're retrofitting systems now, those systems that are receiving the PNT data, they should have ways of taking a look at that data, deciding its validity, and deciding what the appropriate action is, rather than immediately responding to what they believe, or immediately responding and just assuming that the data is coming in. So with this, we really talk about how this PNT executive order is going to be implemented, and then talk to you very briefly about how DHS does its PNT strategy to mitigate risk. So I think most of the people on this call know, or they wouldn't be on the call, it really affects just about everything we do, everything from precision agriculture, which more and more drones are being used nowadays, to telecommunications, to shipping, to moving containers, to even exploring oil at depth in the oceans. There's just so many uses of GPS, and a lot of these systems are built under the construct that I talked about earlier. They assume that PNT data will always be available, and then they assume that that PNT data will be right. So as soon as the PNT data comes in, it's not analyzed, it's simply acted upon. And those are some of the things that we really want to change. So as we talk about responsible use, start thinking about not just the receivers, but talking about the systems that need those receivers and how we can build those more secure and resilient. So as the president signed the executive order back on February 12th of last year, and so what that did is it directed the Department of Commerce through NIST, the National Institute of Standards and Technology, to develop PNT profiles. Many people are familiar with the cybersecurity profiles, and NIST adopted that construct so that we can now have a way of assessing our risk associated with the use of PNT, how systems could be affected, and then levers you could potentially take to mitigate against those vulnerabilities. I am very happy to announce that NIST released the first draft of those PNT profiles just this past week. If you go to the CISA.gov website and search for PNT, you can see those websites, or simply search for NIST PNT profiles and you will find those. So NIST is looking for feedback, and the more feedback we get from industry and the private sector, the better off we'll be. And why is it important for the private sector? Because DOE, Department of Energy, Department of Transportation, and Department of Homeland Security are going to start conducting pilots. And as we become informed of those pilots, we'll develop potentially other profiles. And we're also doing vulnerability testing, which will lead into additional profiles. As we develop these profiles, companies that want to do business with the federal government will be required to show, if their system is highly dependent on position, navigation, and timing services, that they have identified the risk and are able to explain what is the residual risk after application of necessary mitigation measures. So if you're going to be involved in contracting with the federal government, it's a good idea to be involved with development of the profiles, because that way you can shape what's going on and really make the profiles more effective. And I come out of the U.S. Army, and one of the things the Army always tells you is the things that people do best are the things that the boss checks on. And so we have provisions in the EO that says we have to report back which federal agencies are adopting the position, navigation, and timing profiles. We have R&D efforts, and DHS is also, and NIST is also working to make PNT available from NIST over fiber, which would really lead into Dana's position on the last one. If you're going to have a fiber optic network, you're going to need a way to inject timing into that network. Overall, this is DHS's holistic view of mitigation. The ones that are in green are things that we've changed in results, or not as related to the executive order. And we think these build upon each other. We do vulnerability assessments. In the past, we really focused on the receivers. Now we're focusing on systems impact. We engage and educate users so that we provide best practices. But now we're also working with end users to assess what the downstream impact is going to be. We are working with the conformance framework. We expect that to be released soon. What that is if you go buy a GPS receiver now and somebody tells you it is a secure and resilient GPS receiver, you really have no way of telling what level of performance that receiver will have. So we've been working with industry to be able to stratify that and have a common lexicon. And then once again, to complement what Dana said, we believe that alternate PNT services and determining, do you actually need relative PNT services, or can you do it locally? If you have a localized network, can you simply remain synchronized locally and maybe not depend on external delivery of PNT services? So all of those things eventually lead back to the question of responsible use of position, navigation, and timing. As we move forward, every time that we're designing a system where we are going to be relying on PNT services, we should ask ourselves, can the system recognize whether or not the data is available to it? And if data is available, what is the trustworthiness of that data, and how will that system respond if the data is either not there or it cannot be trusted. So with that, very happy to take questions at the end. I look forward to that, and I'll turn it over to Diane so she can give you the Department of Transportation's overview of what they're doing. So thank you very much.
Good afternoon. This is Karen Van Dyke from the Department of Transportation. And I'm very happy to be able to participate on this webinar today. And there we go. So I serve as the Director for Positioning, Navigation, and Timing and Spectrum Management in the Office of the Assistant Secretary for Research and Technology. And Jim, I think you were referring to Diana. Diana Fritsch-Cartroth is our Deputy Assistant Secretary, and really appreciate all of her leadership and support for our PNT activities. So I really enjoyed the two briefings from Dana Goward and Jim Platt, and very much ties into our focus on resilient PNT. But to sort of set the stage, I do want to talk about the ongoing efforts within Department of Transportation and predominantly the Federal Aviation Administration on focusing on UAS technologies. So unmanned aircraft systems are fundamentally changing not only aviation, but also the way we live and do business. Drones are reinventing industries and creating new ones every day. And the promise of full integration of drones means a future where we have better healthcare, safer working conditions, faster commercial delivery, and so much more. And certainly in this COVID environment, I think we've all have certainly a better appreciation for the need for contactless delivery and the ability for unmanned area vehicles to deliver that. So that doesn't come without its challenges, and the safe integration of unmanned aircraft into the national airspace system is a significant challenge. So the Federal Aviation Administration has been making great strides in developing the technical and regulatory standards, policy guidance, and operational procedures on which successful UAS integration depends. And based on the last two presentations, certainly resilient PNT is at the heart of that. So we want to talk a little bit about what the current integration status is for UAS into the national airspace system, and also talk about considerations for PNT as well as radio frequency spectrum, as well as some of the challenges. And I think you've heard some of those already in terms of delivering reliable PNT operations. So earlier this year, the Federal Aviation Administration published the third edition of the Integration of Civil Unmanned Aircraft Systems into the National Airspace System roadmap. And this roadmap provides an update on the progress that the FAA has made so far in achieving UAS integration. And it also gives a 5-year outlook on the path and challenges that lie ahead, including detect and avoid technologies and the demand for advanced air mobility, or AAM. So there are three broad areas that are really advancing in parallel. So the FAA has UAS facility maps that show the maximum altitudes around airports where the FAA may authorize Part 107 small UAS operations without additional safety analysis. And the FAA also has been working very closely with NASA and industry to implement unmanned traffic management. And finally, the FAA is working also closely with NASA and industry to implement urban air mobility and advanced air mobility. And you see the graph on the side in terms of the integration strategy resulting in the full integration as the end goal. So this figure shows the path in the introduction from UAS in the NAS and some of the previous accomplishments. So right now the FAA is leveraging an operations first approach to authorize UAS operations using existing regulations. And through the use of the current regulations and associated exemptions, they're paving a path forward for development of future policy and regulations. And simultaneously, the FAA is conducting UAS research in a building block approach, as you've seen in this graph, for full operational capabilities. And as this research progresses, it certainly will inform rulemaking and policy activities, and the FAA will increasingly be able to allow more complex UAS operations over time, including in the future autonomous beyond visual line of sight operations and flights over people not directly participating in the operation. So the FAA has been involved in an integration pilot program, IPP. There have been 9 IPP lead participants that have been evaluating a host of operational concepts, including night operations, flights over people and beyond the pilot's line of sight, package delivery, detect and avoid technologies, and the reliability and security of data links between the pilot and the aircraft. And we've already seen direct societal benefits, such as faster medical test deliveries via drone to labs in North Carolina, pipeline monitoring in Alaska, package delivery in Virginia, and new and novel ways for public safety to engage with the public in California. So as we look to the future, we must consider the challenges of remote ID implementation, counter UAS issues, as well as UTM and AAM. The roadmap also focuses on the challenge of the pace of UAS innovation and the human element, societal acceptance. So one of the key components that the FAA has undertaken is something known as low altitude authorization and notification capability. So the LAANC is an innovative collaboration between FAA and industry. It provides access to controlled airspace near airports through near real-time processing of airspace authorizations below approved altitudes in controlled airspace for Part 107 operators. And it's currently available at approximately 400 air traffic facilities covering 600 airports. So the LAANC provides the UAS operators with access to the controlled airspace at or below 400 feet, awareness of where pilots can and cannot fly, as well as the to the air traffic professionals' visibility into where and when UASs are operating. So as we look at PNT, we have broken this out into 3 separate use cases. So outdoor visual line of sight, outdoor beyond visual line of sight, and confined environments, and taking a look at how to achieve PNT based on current research for those 3 use cases. And I think also very much want to be informed by the work that Jim talked about with the executive order, as well as appreciate Dana showing the national PNT architecture and how all of the pieces fit together in terms of that architecture. So for outdoor visual line of sight UAS operations, and we're talking about small or micro-size UASs, typically operating under CFR 14 Part 101 or 107, under a 400-foot altitude. The navigation is performed by the operator with some level of autonomy, which is needed in case of loss of the control link. So that the typical PNT systems are GPS, either augmented with the wide area augmentation system or without, using barometric altitude sensors, as well as altitude stabilization. Those can be coupled with MEMS IMUs for inertial stabilization, as well as a magnetic compass for direction information. And then in terms of data processing and data fusion, the algorithm complexity is widely varying based on our research, and depends on available processing power on the UAS and the specific application needs. And the position and attitude estimation using extended Kalman filter, the GPS, IMU, and magnetic compass data. And it also might be partially performed on board or on the control station using telemetry and other payload data. And for the spectrum, these are typically unlicensed 2.4 gigahertz and 5.8 gigahertz links. Now, when we look at beyond visual line of sight operations, these will be larger UASs, so we refer to them as medium and large, operating under Part 91 or 135. The navigation might rely on human or autonomous systems, and as discussed previously, are going to need at least a minimum level of automation, such as the detect and avoid function, as well as being able to safely autonomously maneuvering to a landing location in the event of the loss of the control or telemetry links. And the previous, presenters talked about the concerns, any interference, whether that's intentional or unintentional, that might affect resiliency. So that certainly is a big concern, and I think embracing the executive order, working through the PNT profiles, the vulnerability assessment and testing is really going to be key. So the current work has certainly focused on TSO compliant WASP GPS receivers using the receiver autonomous integrity monitoring and failure detection algorithms. Also dual MEMS for stabilization, the traffic awareness beacon system, and the 915 megahertz primary control link, as well as backup command and control links. And then moving on to UAS operations in confined environments. So this may be within buildings or tunnels for inspection, indoor mapping, or maintenance, and other indoor applications where certainly you're not going to have GPS or GNSS availability and need to look at other PNT solutions such as ultrasonic capabilities, fixed beam or scanning lasers, cameras without LED lighting, necessarily for object identification and localization, multiple IMUs for stabilization and localization aid, as well as altitude measurements processed from LiDAR and camera data using the SLAM or VSLAM techniques and visual odometry. And for the spectrum, again, typically on the unlicensed frequency bands in the 2.4 and 5.8 gigahertz band. So in terms of the challenges, certainly for me, coming from a PNT perspective, we absolutely need a reliable and resilient PNT. So I think working through this, understanding the technologies that best suit the various operational environments, conducting testing of interference, both jamming and spoofing, and understanding what it means to be resilient in the various UAS operating environments. Understanding other environmental challenges in terms of line of sight, obstruction, multipath, potentially impacts from precipitation and fog, as well as varying temperatures. And then there's other concerns in terms of non-compliant UAS, UAS that perhaps are using non-compliant frequency bands, and then intentional violation of regulated airspace and counter UAS technologies. So with that, again, appreciate being able to participate in this webinar and look forward to the questions at the end. And I believe at this point, I'm turning it over to John Fisher. Thank you.
Okay.
I think that I'm supposed to come back.
Yes. Yeah. Go ahead, Omer. I think you are too. Go ahead.
No worries. Okay, so thank you, Karen, Jim, and Dana for those very interesting and informative presentations. Now, John and I will present a couple of use cases for resilient PNT and unmanned systems. Now, before that, we have a quick poll to see. Okay. Now, we have a quick poll to see how problematic GNSS jamming is to your unmanned aerial system platform. Now, either it's not at all, meaning that your unmanned aerial system platform can perform even when GNSS is fully jammed. The second option is somewhat problematic, meaning that missions will probably take longer to execute. It is problematic, meaning that without GNSS, missions are impacted or might even be aborted. Or it is catastrophic, meaning that unmanned aerial systems platforms cannot simply operate at all without GNSS, cannot lift off, cannot land, etc. Please make your selection now. All right, so as we probably could anticipate, most people think that it is highly problematic, meaning that without GNSS, missions are impacted or aborted. The second option then is it is catastrophic. Obviously, some unmanned aerial systems simply cannot operate without GNSS. And I'll be happy to go through our case study, which actually goes to show exactly that. Okay, so as I said, I'm CEO of Infinidome, the GPS security company. And I'd like to take you through a little bit of history, how Infinidome was founded, a little bit of Infinidome origins, if you will. Back in 2018, we saw in Israel kites and balloons carrying fire coming from the Gaza border crossing into Israel. And those created really horrific fires, burning up fields and actually caused real risk of life. And that's when the IDF understood that they need to do something differently. They need to tackle this problem differently, and they need to show flexibility that it simply can't show, which is why they tapped in mainly startup companies and drone integrators to start assembling these systems that can go after and track these flying things over the border and even take them down. Now, not long after, what happened is that the guys at the other end of the border understood that by GPS jamming, they can critically impair the operation of these drones. So using off-the-shelf jammers that they bought literally online and amping them up with amplifiers or directional antennas, they could actually bring down and critically impair BVLOS operation of these multicopters. And basically, any autonomous or semi-autonomous mode was simply disabled because of this GPS or GNSS jamming. Position, altitude, hold, mission modes, all of these things, or even the go home mode, basically was rendered useless. And what happened is that when the autonomous mode of position hold goes down and is disabled, we see these drones drifting away and at some point even crashing into the ground because their battery runs out because they can't come home. And this is what happened. And more or less in that time was when we showed our first prototypes, our GPS dome prototypes, either in OEM form factor or in a closed form factor. And they were very different from what the industry knew until then. They're GPS protection solutions with two elements that can attenuate the attack from a single direction of jamming, but they're significantly smaller and lighter than anything in the that was then in the market and still is. And that's actually, they're still prototypes, and that's actually when we were tapped in by the IDF to say, hey, we need to integrate those systems on top of those drones. So that's when we started manufacturing the first manufacturing batch of our first products. And I'm happy to say that we were selected and retrofitted on top of those drones and we're able to make any kind of these multi-copters a lot more resilient to these kinds of GPS attacks. Basically, what they did is they integrated our solution as a secondary GNSS system to the PixHawk controller. So when the primary system was jammed, they reverted back, or they fell back on the secondary protected navigation system. And we didn't only give them early indication that, hey, the multi-copter is under attack right now, but it did provide them an extra layer of protection in these hostile environments, making their systems literally about 50 times more resilient to these GPS attacks than without our solution. And with that, I'd like to pass it over to John. John, please take it away.
Great. Thank you, Omer. That was really interesting. You folks are really on the front line of what we need for that. So I'm going to give another use case, but first we're going to do another poll question. So we're asking you, what is the primary mission of your unmanned system? And please check all that apply. So under data collection, sensing, if you're doing what the military might call an ISR mission, that's all under there. Delivery or transport, as we saw in those examples there, whether the delivery is a package or people, like an Uber air taxi or something someday, maybe we're not there yet, or communications relay. We know cellular companies are offering using UAVs and disaster recovery things to replace damaged cell towers, things like that, or military applications, or robotic actions. I think we saw examples of maybe precision agriculture. So hopefully you've all voted soon and we can see the results, and there are the results. So great, yes, data collection, ISR, things like that seem to be the predominant use case. Cameras, things like that. Great, so that's perfect. I think that's a perfect lead into then this use case that I'm going to tell you about. And so let me click on it. It'll be about payload. So if I do that to advance the slide, great. So pretty just a simple but very important point I want to get across here is that when we talk about PNT, position navigation, we talk about the navigation device on your UAV, or even your unmanned system, even on surface things. This applies there. I'll focus on the UAV case because it's probably maybe the more difficult case, but the same idea applies even if you're a surface vehicle. So the idea is that you really have two separate things you're trying to do. One is control your flight, fly the aircraft, and what you'll need for a navigation device will be linked to the performance of the airframe, the fixed wing, rotary wing, and even though it's a UAV, we're seeing more and more, especially as Karen had mentioned, the flight of a UAV over populated areas, over civilian airspace, things like that. We do have to worry about safety, and so okay, there's no pilot, but safety. And for our manned aircrafts, we have all kinds of safety certifications, and a lot of those are going to apply to the UAVs, especially the mid-size and larger ones. And so there's all kinds of safety certifications that you have to be worried about. Because of that, the whole safety qualification, the technology will evolve slowly. Any kind of update you do to the hardware or software will require recertification, maybe reflight testing, even interfaces and changing that. So it's a very careful, slow-moving process. On the other side is you need position and timing for your payload. As I saw that almost 3/4 of the audience is doing sensing things. So you're either using cameras or pointing an antenna, looking at which way the things are pointed, and you need very high precision angles, attitude indication, if you're geo-time stamping this data, you need some, your mission is going to be determined how accurately you can do that. You may need a lot more accuracy than you need for just flying the vehicle. And so the performance is linked to your mission. And the other thing is you also need time. For flight control, you really don't need precision time, but a lot of things you need time and also the derivative of time, which is frequency. So again, if you have any kind of either communication system or radars or any kind of receiver transmitter, you can have precise frequency, low phase noise kind of frequency sources, and using a GPS disciplined oscillator for those kind of sources has great advantages. So that's why we lump it all in and we call it PNT. So the big advantage, the big advantage here is this kind of technology, your sensing technology, your IMUs, your inertial measurement units and stuff, especially with the advances in MEMS, is advancing very quickly. And so if you have to go through the slow process of flight control, you may not be able to use those more advanced things very quickly. So what you can imagine I'm driving at is, why not then use two separate PNT devices, a separate one for your payload, a separate one for the airframe. And believe it or not, even though you're saying, oh, I'm doubling having two units, you'll actually lower your total cost of operation over the lifetime of the UAV. Your payload can keep pace with the latest technology. You still have safe operation. There's no risk that as you change out your payload that you're going to change the certification of your aircraft. I use the example of our PNT device, but there's many that are even be small, what we call swap size, weight, and power. So has all that advantages. But you don't point out, you're only giving up the safety of flight. You're not giving up, because it's a very expensive thing. The type of unit can be 10 times the price of a non-certified one, but you're not giving up the ruggedization. And as you saw in Omer's presentation, there's real advantages of using anti-jam antenna systems, in that you can use still the anti-jam antenna system and one single thing and split that off into two. So a very good use case there. So I think that's it for my thing. Let's get to the questions and answer session. First, I want to thank everybody for submitting questions. We got a number of great questions already, so I'll get to it. Let me start with the first one. How can existing commercial assets such as satellites be leveraged to provide resilient PNT? And Jim, I think that might be a good one for you.
Yeah, thanks a lot for that question. I appreciate it. There really are no obstacles to integrating additional sources such as LEO Constellation's PNT services into the systems. The one thing that we would encourage as we do this is that every time you introduce a new position, navigation, and timing service, you may be introducing new benefits, but you also have to be aware of the possible risk that it could also introduce into your system. So there's lots of signals of opportunities out there. There's more and more constellations going up relative or almost on a monthly basis. So the idea here is, if you can use them, it's good to incorporate them if you understand the risk and if you understand the benefits of incorporating them into your system. Over.
Great, thanks, Jim. This next one is about air transport. So Karen, it's probably best for you. How can the existing commercial air transport network be extended to support UASs?
Yeah, thank you, John. So I think it's important to recognize that the Federal Aviation Administration has spent a long time, actually over 6 decades, working with the airlines and other industry partners to create what is the safest airspace in the world. So certainly from a DOT perspective, we're ready to utilize everything that we've learned from manned aviation to make sure that the UAS industry can reach its full potential as quickly and safely as possible. So I think we're focused a lot today on technology and the importance of PNT. But just as important as technology and the infrastructure rollout, I think community engagement and the work that's being done at the local state level is really important for those who will be hosting the relevant infrastructure. And that infrastructure rollout requires detailed planning, zoning, and then I think we recognize that the public does have real concerns regarding UAS operations with respect to safety and privacy, and that's got to be a key component because if people don't feel safe with the UAS operating around them and they have fear of drones intruding into their private lives, then the UAS commercial opportunities will be limited. And I think that's one of the challenges that we need to focus on and address. Thank you.
Great points, great points. Thank you. Okay, next one about alternative radio navigation. I think, Dana, you'd probably be best for this one. What is the real need for alternative radio navigation systems to GNSS when there are high performance clocks, IMUs available?
Well, thanks, John. So certainly IMUs and clocks are a part of many solutions, but only just a part. And there's a couple things, as with any technology, you need to consider, but specifically for clocks and IMUs. First, there's the cost, and you will be surprised to hear that the better the clock or IMU, the more expensive it is. Second, IMUs and clocks are generally only good for relatively short periods of time and short distances. And again, it varies with cost. The most expensive ones, though, used by the Department of Defense for cruise missiles and such, really only get up into the minutes. Depending on how much of an interruption and how long you want to go without using space, there could be some challenges there. I should say, without using another system besides the IMU or the clock. The third is there are you have to be careful how your clock or IMU is integrated into your system. It probably goes without saying, but many existing instantiations we have seen are very susceptible to being led away because of the way that the GPS or GNSS signal is prioritized. So if there is a jamming or a spoofing event, the IMU can be led away because priority is given to the external signal. I should also mention that the first symptom of jamming often looks like spoofing because the signal is interfered with and it gets drifty. It moves away from where it really is before the signal either goes away or the receiver stops using it. So there's like I say, there's a number of challenges, and they are part of the system, but there's no silver bullet. And really that's the message in terms of having an architecture of systems, a PNT architecture for the nation, so that everybody has the position, navigation, timing wherever and whenever they need it, regardless of what's happening in one or maybe even two systems in terms of disruption. I mean, PNT is essential. And when you don't have something essential, bad things happen. So we need a systems engineering approach to ensure that pretty much everybody has it all the time.
Great, I couldn't agree more, Dana. Thank you, thank you. The next one, Omer, maybe you could handle this one. Can you give us a use case for the logistics industry?
Sure, yeah. By logistics, I assume that we mean truck and freight and transport of cargo. And this is a really, really interesting use case because on one hand, you know, when you jam the GPS or the GNSS of a truck carrying expensive cargo, it doesn't make the truck crash, right? It's not like a drone that crashes into the ground. Because after all, at least today, we have a driver driving that truck. However, jamming the GPS or the GNSS link of that truck makes that truck completely disappear from the grid, completely disappear from the SOC, from the Security Operations Center, where they track where the cargo is. And that basically enables the truck to be robbed very, very easily. So I'm happy to elaborate a little bit on, for example, what happens right now in Mexico, which I think is a very interesting use case. So on average, in 2018, every 10 minutes, a truck was robbed. And on 85% of those robberies, a GPS jammer was used. So this is like the go-to default tool of the bad guys, mainly of the cartels over there, enabling them to steal the cargo from these trucks. So at the end of the day, these trucks are being tracked by what's called a telematics unit that sits on top of the truck. And that telematics unit, has a feature of a GPS tracker, but it has tons of other features, like fuel usage and whether the trunk is open or not. But at the end of the day, when you want to defend the GPS of that truck, it means that we have to basically protect that telematics unit. Interestingly enough, if you protect that GPS, you still have a vulnerable link, a much more robust than GPS, but that is the cellular link that connects that telematics unit to the SOC itself. So to wrap this use case up, defending GPS for logistics for these trucks is super important. And at Infinidome, we have developed a product specifically for that, and we'll be happy to contact anybody who's interested in that use case. And we're working on very exciting stuff on making not only that GPS link more robust, but actually the cellular link as well. And we'll be happy to touch base with anybody interested in that.
Great, that's fascinating. Sounds like a wonderful use case and really helpful for this. We're at the top of the hour, so I think we're out of time. But I guess just before we do, we have one last quick poll question. Maybe we could put that up. There we go. Yeah, would you like to speak to someone about resilient PNT for your unmanned system? So please click that yes or no, and we'll get back to you. So thank you so much for the speakers in the audience for your participation. We're out of time, but we've collected those questions you've had, and we will try to respond to all of them. So thank you again, and thank you. We hope to see you, I believe, next time. Wait, is there anything we have about telling you when the next time is? Yes, we have another one planned in December, another one of our webinars. So registration will open in next week, and we'll look for emails about that. Okay, December 10th it'll be, and look for information about that. And also you'll receive links to the slides and the recording. And it looks like I'm out of time. So thank you all for attending, and we hope to see you next time.
Thank you, Jen.
Thank you very much, everybody.